All right, I'm ready.
All right, so we're doing sequences and series.
Yeah.
So a series is basically a sum of the elements of a sequence. That's what a series is.
Yeah.
It's a sum. And by the way, this is a sum right here. This means sum up these 12 elements. There's from n equals 1 to n equals 12, where 3 times 4 to the n minus 1 is the definition basically of your term, of each term. So if we wrote, the best thing to do for this to start at least is just to write them out. So if n equals 1 or n equals 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then my series are going to, or my sequence, or the elements of my series, the terms, sorry, would be 3 times 4 to the 1 minus 1. What's 1 minus 1?
0.
0. And what's 4 to the 0?
1.
Good. So this is 3. Plus, you're going to be adding them because it's a summation, right?
Yeah. Is it a metric one?
Well, we're going to find out in a second. 3 to the 4, or 3 times 4 to the 2 minus 1. So you want to plug it in there?
Yeah.
So that would be 3 times what?
It's 12.
Good. 3 times 4, which is 12, plus, and we're going to keep doing that. What's going to happen each time?
They're going to go up by multiplication of 4.
Yeah, you're going to multiply that 4. You're going to multiply now that by 4 again. So we're going to multiply this 12 by 4, and you're going to get what?
48.
48. So you noticed what happens each time.
Yep.
You multiply it by 4, right? So you just asked a question. Is this a geometric?
Yeah.
Can you tell? It's geometric, right? So there's formulas for this, right? We don't have to actually multiply all these out. We recognize, oh, that's a geometric. In fact, the more you do this, the more you could have recognized that right from the beginning, because each time you're going to keep multiplying by the same thing. Do you remember the geometric formula? A sub n equals the first term.
Yeah, r n minus 1.
Very good. So you can actually see, oh yeah, that's exactly what this is. So r is 4, right? And a sub 1 was 3, right? And so there's also another formula for the sum of a finite. This is finite because there's only 12 terms. There's sum of a finite geometric series. And do you have that formula?
Well, like the a sub n equals.
Not a sub n. That's each term.
Oh,
what's
like
the formula for the sum?
S sub n?
Yeah, S sub n for geometric. What is it?
Yeah, it's a sub 1. Why am I forgetting this? Because it's the big one. A sub 1 minus r to the power of n over 1 minus r.
Is it all to the power of n or just r to the power of n?
R to the power of n.
Okay, all over what?
1 minus r.
Good. So we have all those things, right?
Yeah.
I actually don't remember. Are you sure this is the right formula? I don't have that one memorized right now.
Yeah, it is.
Yeah. Okay. So this is finite geometric sum. Finite geometric sum. Or finite sum of a geometric series. Right? And so let's just plug them in. So the 12th, we're finding S sub 12, the first 12, and the formula is going to be the first term.
Yep. 3
minus
4
to the 12th all over
1 minus 3.
1 minus 4, because r is 4.
Or yeah, 4.
Right? Which equals You can just take your calculator out and punch it in if you want.
It's like
that equals
592404.33.
good. I'm just going to do it to make sure. All divided by, I'll just punch it in even though I could type in -3 and hit enter. So it's 5592404.
Yep.
That doesn't make sense. It would not be it would not be a fraction like that, because I don't have any fractions here. So that formula must not be right. Let me look up the formula real quick. Oh yeah, it's a⁻1 times 1 minus r to the n, maybe divided by n. There it is, right in the middle there. a⁻1 times 1 minus r to the n all over 1 minus r.
Oh, yeah.
That's the formula. Yeah, I knew something didn't look right with that. It was close. You were close to the right thing. But it's a⁻1 times 1 minus r to the n all over
1 minus r.
1 minus r. Is that right?
Yeah.
Yeah, and r can't equal 1, of course. Okay. So your formula or your answer should be it's going to be 3, the first term, 1 minus 4 to the 12 all over 1 minus 4. Open my calculator. There it is.
1677215.
What did you say it was?
1677215.
That looks more like it. 1,677,215. Okay. Got it? See how that works?
Yep.
Oh, did you put them on the pages before? Is it this? Write a recursive definition?
Yep.
All right. So a recursive definition means you're going to start with the first term and maybe even the second term, but you're going to define every other term based upon the previous term. It's going to be a function of the previous term. That's what that means. That's what a recursive one is. You're defining it based upon itself. So what are we going to do? We're going to start. What's the relationship between every term and the next one? Can you see?
+3.
You're adding 3. So let's start with the first term, and every other term is basically the previous term +3. Got it?
Oh, so you have to just write the a(n minus 1) and then just write whatever it is?
Yeah, this basically means the previous term.
Okay, so this is easy enough then. So the next one would be a⁻n equals a(n minus 1) divided by 2.
So start with a⁻1. What's a⁻1?
16.
Good. And what is each term? What did you tell me to write?
Divided by 2.
So a sub what?
You could do 1/2 times a sub.
No. It's this. You write a sub n minus 1,
yeah,
which I think is what you said, divided by 2.
Divided by 2.
And that's correct. So let's just take a look at an example. See if we did it right. What would a sub 7 be?
What do you mean?
Or actually, no, a sub 4. What would a sub 4 be? We don't have a sub 7 on here. What would a sub 4 be? According to our definition, what would a sub 4 be? It would be a sub
8 divided by 2.
It would be a sub 3 divided by 2, right? So a sub 4 was 2 and a sub 3 was 4. Is that correct? Did we do it right?
Oh, yeah.
You get what I'm saying?
Yeah.
You see that? If n was 4, then there's your a sub n, and there's your a sub n minus 1.
Okay.
Okay? Do you get how you're thinking through that? It's kind of like a different way to do function notation, basically. Okay?
Mm-hmm.
Right? An explicit nth term formula. So an explicit formula is the opposite of a recursive formula. This is where you define it a sub n based upon n, not a sub n. You define it based upon n.
Yeah.
Okay. So this is where those formulas come in really handy. For an arithmetic, the formula was a sub n equals the first term plus d times
n minus 1.
Right. And if it was a geometric, it would be the each term equals the first term times r to the n minus 1. Right?
Yep.
So if we want to write this as an explicit, we're going to have to basically find this right here.
Yeah. Do we have to find
Okay,
this?
so yep. So the way I like to do this, or to think about this, is here's a sub 2. There's a sub 3, a sub 4, and a sub 5. So this was 15, and this is negative 21. And what are you doing each time?
Subtracting by...
Well, no, just tell me what you're doing. When it's arithmetic, what are you doing each time? You're adding what each time?
Amount.
You're adding the same amount each time, right? Or subtracting, right?
Yeah.
So how many times did you add, when you had 15, how many times did you add d to that?
3.
You added it 3 times, and then you got what?
Negative 21.
That's right. So there's your formula that you write to solve for d. Got it?
Oh, okay. So
what does d equal? 3d equals negative 36.
Yeah.
So what does d equal?
12 or negative 12.
Negative 12. So there's your d. What else do we need?
What you do is you basically subtract the 2 aces, put that on the difference, and then just have it equal.
Yep. That's exactly right. That's exactly right.
Yeah. So it would be a sub n equals.
So now hold on. We got to go backward and find a sub 1 now. What would a sub 1 be? So now going back this way, we're going to have to do the opposite, right? We're going to subtract the d from 15 to get a sub 1.
Okay. Oh, just 3?
So we're going to have to basically add 12 to it, right? Yeah, so it's going to be 3. So there's a sub 1 and there's d, and so now you can write the formula out. A sub n equals what?
A sub n equals 3 plus negative 12 n minus 1.
So I'll just write minus 12 times n minus 1 like that.
Yeah. Equals 3 plus.
And there's other ways you could do that problem. There's other formulas you can use for it.
So if you get the difference, you can assume then, right? Like what?
Yeah, you basically need to find that difference. Another way you could do that problem is you can kind of write. You can do it like with points. Do you remember with algebra 1 where you would use points? So this would be basically 2 comma 15.
Yep.
And the other one would be 5 comma negative 21. And you can do that slope. You can find the slope. M equals 15 minus a negative 21. That's the rise over the run, which is 2 minus 5. So the slope is 36 over negative 3, which is negative 12. And that's essentially, that's your slope. Do you see how this is just your slope?
Yeah.
And then you're really not trying to find the y-intercept, because that would be a sub 0.
Yeah.
Right? But you can if you want to, because that's still a formula. See that you don't have to write the formula like this. You could have distributed this, and you could write it in a different way. Another way to write it is to write 3 minus 12n plus 12. So then you add the 3 and the 12 and you get 15. So you could have written a sub n equals negative 12n plus 15.
Yep.
Did I do that right? No, I don't think I did that right. What did I do wrong there? That's not the right formula. Negative 12n plus 12. Did we do this right? The first term was 3 minus 12 times n minus 1. Why is this formula not working out right for me? I should be able to plug in 1. Oh, yeah. No, hold on. 3 wasn't the right answer. 3 wasn't the right answer. That was dumb of us. It's not 3. You're doing negative. So you're adding 12 to 15. My bad. How did I not catch that? So this should be 27.
Oh.
Right, you're going the opposite direction, going to the left. So this should have been 27. So this should be 27.
Yep.
Right, so this right here shouldn't be 15. That should be 39. So this is another way you could have written that formula. It doesn't look the same way, but this looks more like a slope-intercept form. Right?
Yep.
So look at what I'm showing you up here. You could have just done that to find an explicit formula for the nth term. You could have found the slope and then used point slope form. You remember doing this? Where you do y minus y sub 1 equals x, the slope times x minus x sub 1, and then just solve the equation.
Yeah.
So negative 12x plus 24, y minus 15. So y, or which is a sub n, right? Y equals negative 12x plus 39. You could have done it like that. So your answer is a sub n equals negative 12n plus 39. Okay. Which is that same equation. So either way is possible, because an arithmetic formula is basically just a line. It's just a line, because it's got a common difference, which is its slope. Okay.
Okay.
You can probably do this one on your own. Again, this one, see how this one's a little bit harder because they're farther away from each other. But you can kind of see the pattern. What do you do? Again, what I would do for this one is just make it 2 points, because that's just easier. And use those to find the slope, which is your common difference. Mm-hmm. Common difference is the same thing as the slope. Okay. Okay. And then to back this off to get to a sub 1 would take a while if you found that difference and you kept backing it off. So it's really just easier just to use one of these like I did here, one of those points, and put it in slope intercept form, and then just rewrite a sub n and n. Yeah. Okay. I'm skipping that one just so I can get to these other questions that you have. Okay, so here's the formulas that they were wanting. The explicit formula, we just talked about this, is a sub n equals the first term plus the common difference times n minus 1. Seems like you got that, okay?
Yeah. And the second one is a sub n equals n over 2 a sub 1 plus a sub n, right?
Correct. A sub n equals a sub 1 times, oh, sorry. You were doing that other one.
Yeah.
To the n minus 1. Yeah, and this one equals, what'd you say? S sub n equals what?
N over 2 a sub 1 plus a sub n.
Good.
And then s sub n equals a sub 1 minus r to the n over 1 minus r.
There you go. Determine whether it's geometric, arithmetic, or neither. So to determine that, you just subtract them and subtract them.
Yeah, like the first
so,
one there.
So there's 1.5 here, there's a 1.5 here, but there's not a 1.5 here, there's 3. So it's not arithmetic.
Oh, it's neither.
To find out if it's geometric, you divide 1.5 divided by 0.75, and you ask, does that equal the next one's 3 divided by 1.5? So punch into your calculator, and if all of those are equal, that's 2. 3 divided by 1.5, is that 2? Sure is. How about 6 divided by 3? Is that 2?
It's geometric.
Yeah. And yes, they're all 2. So yes, it's geometric. Then write the explicit nth term formula. So what would the nth term formula be? A sub n equals
0.75 times the ratio. It's like dividing, or it's multiplied by 1/2 then, right?
Nope. See what I did here? You take a term and divide it by its previous one. The term divided by its previous. The term divided by its previous. The term, and what do you get every time?
2.
Yeah, so that is your common ratio is 2.
Well, but isn't it technically, I thought my teacher told me if it's okay, maybe not. That's true.
Yeah, just look at how it works. If I plug in 1, what do I get? It goes away and I just get this.
Yeah.
If I plug in 2, what happens? It's 0.75 times 2. What's 0.75 times 2?
1.5.
Yeah. You get it?
Yeah.
If I plug in 3, etc. Okay.
And then
so for this next one, compare, subtract, or add, right?
Yeah.
No, subtract. What's the common difference? What's negative? What's that minus negative 2/5? And is that the same thing as the next thing subtracted? 0 minus negative 1/7.
Okay.
Is that the same thing? I don't think it is.
No, I don't think so.
Because common denominators, I would have to get, this is negative 5/35 plus 14/35, which equals 9/35. That's that difference, and this difference is 1/7.
Yeah.
So these do not equal each other. So no, it's not arithmetic. And then geometric, again, divide one term by the previous one. And is that equal to divide one term by the previous one? 0 divided by negative 1/7. Obviously, that's not true because this is 0 and that's not. So no. So neither.
And then you just write what it is, right? It's like,
yeah, you just say neither. Then you can't write. Oh, well, actually, can you write an explicit formula? I'm not really sure if you can.
yeah, you have.
They want you to write an explicit formula. Do you see what's happening? Oh, I kind of see what's happening. You see how the numerator is increasing by 1?
Yeah.
And the denominator is increasing by
2.
but so the numerator is a arithmetic sequence, and so is the denominator.
Yeah.
So a sub n equals the top would be -2 plus 1 times n minus 1, right? Because the common difference is 1, starting at -2. And the bottom starts at 5 and goes up by 2. So you're adding 2 times n minus 1. Do you get how I came up with that?
Yeah.
And you could simplify that if you wanted to. So that equals n minus 3 all over 2n plus 3. That would be your formula.
Okay.
And for this last one, is there a common difference? Let's find out. That's 12. That's 12. That's 12.
It's 12.
It's arithmetic.
Yeah, so that one's pretty simple. Plus 12 and minus 1.
Yeah, and you know how to write that formula. All right, good?
Yep.
All right, good job. I'll see you next time.
All right, thank you.
Later.